NPI.
All right, so we found out, we knew that Maxim Integrated is now part of Analog Devices, but we really found out now because we were going to link to the Maxim Integrated Twitter account, and it's like, nope, gone. So this week's INMPI is for sure, it's Maxim Integrated, but it is Analog Devices.
Okay, it's both.
It is, though.
The part number is a MAX part number. So this week's INMPI is the MAX31888. It's a new high precision, high accuracy, one-wire temperature sensor that's available from Maxim, which I think purchased Dallas Semi because the DS series was the DS18B20, and this is clearly kind of a next generation. So yeah, these companies, they just kind of squish together a lot, but that's great. They're all Analog Devices now. Congratulations to ADI. So again, this week's new product is the MAX31888. It's a one-wire temperature sensor, but it also has a unique NIST traceable 64-bit identifier, and it has like 3 GPIO as well. And it kind of does like a lot of stuff going on there, and you know, it's a little bit specialty. It looks like it probably goes into somebody's product. Like I have some ideas of what that might be, but I thought it would be also useful if you have any kind of temperature monitoring that you have to do, especially if you have either a very limited number of pins that you want to use for temperature modeling, because like the DS18B20, this is a parasitically powered sensor. So one wire, like people don't talk about it as much as I2C. I2C is the most popular sensor protocol right now. But one wire, which started with Dallas Semi and is now owned by Maxim, is kind of neat in that you only, like they say one wire, but it's really 2 wires. You need ground and then 1 data/power wire. And that's half as many as I2C, which uses 4 wires, and a lot fewer than SPI that can use 5 or more, because you need power, ground, and then 3 or 4 data lines. So you only need 1 wire, and that 1 wire is used for power and data. You can see the diode inside this simplified block diagram, and it can parasitically power. You just need to give it a single capacitor to help that parasitic power. So like I think a 1 microfarad or so is good enough. And then all you need is the ground wire and the data power wire, and you can chain as many as you want, which is kind of neat. And there's also a special case here where you can use the GPIO pins as kind of pseudo addresses, so you can have 8. You can have as many as you want on 1 wire, but if you want to be able to kind of sub-address them, you can use the GPIO wires as well. I thought, one of the examples they had in the data sheet for what this could be used for is cold chain monitoring. And cold chain monitoring is something that nobody used to know about 2 years ago, and now everybody knows about, because it's how we transport vaccines around the world. Vaccines, some of them have to be kept very cold, -80 degrees, and you want to make sure that at no point do they heat up. So if you have a big box, let's say you have a pallet that has vaccines in it, and the box is maybe 1 meter by 1 meter by 1 meter, you want to be able to measure the temperature at every corner. So that would be 6 different sensors and one in the center, and make sure that at no point does any side of the box get above -80 degrees. You could use something like this, and you would have minimum wiring. Like you wouldn't have to pass a long chain of I2C cables and bus expanders around. You would just use 2 wires, and they all connect onto that 1 bus. Another thing that's really nice about 1 wire is it's designed for long distances. Unlike I2C, which is power ground, SDA, SCL, and some pull-ups, and is really only meant for maybe 200 millimeters. You can easily put I2C bus on with just a pull-up resistor on 200 meters of cabling using a Cat5 cable, which is a lot, like 200 meters total. That's a ton. And there's some examples of different topographies you can use, and it's up to you whether you want to use star or bus or stubs, and they have some examples also of if you have a active driver, like they have specialty chips for active driving of 1 wire, you can go up to 500 meters. So a cable like this that would be very tough to do with I2C, this is a 1 wire temperature sensor. So this sensor kind of builds on the DS18B20 popular series. It's 0.25 degrees centigrade accurate compared to 0.5 degree. And of course, has those extra GPIO pins that the DS18B20 doesn't. It only has one pin for power and data, and then ground. So, it could be good for battery packs, for cold storage, for data logging, ultra low power, temperature, and GPIO control. There's also a handy dandy eval board available that you can use from Maxim, which has a sensor and then an I2C to one-wire converter. If you haven't used one-wire, do check it out. It's very reliable. It's really good for temperature sensing. There's a couple other, there's EEPROM, and I think Microchip also has a secure element that's one-wire as well. So it is available from multiple different manufacturers, and is great when you really just want, one-wire simplicity and long-distance support for sensing.
Okay, available on Digi-Key. You can actually get it.
It's in stock.
Yeah.
It's available right now, both the eval board and individual chips.
There's a short URL. There is the Digi-Key ID. And don't forget, Maxim Integrated is now part of
Analog
Devices. And that's right on NPI.
On NPI.